Dr. Hashemi, the series where partial discharge concepts are explained step by step. Today's episode is about challenges of PD measurement. The PD measurement is a complicated method for investigating the asset health condition. Indeed, you can find different concepts from the partial discharge about the dielectric and insulation materials, but it is not easy to do and it is not easy to interpret the results. During the measurement, the sensitivity is so important. It means your selected tools and method should be suitable to detect the partial discharge in low level and depend on the asset that you want to measure. For example, if you want to detect the partial discharge in high voltage and extra high voltage cable systems, you need very sensitive PD detection method. 1 picocoulomb or less than 1 picocoulomb should be detected by the measurement technology that you have selected. Depend on the asset, sometimes higher sensitivity or lower sensitivity will be needed. And if the system for PD measurement is not sufficient sensitive against the partial discharge events, you cannot find the good results. Another issue about the partial discharge challenges will be related to the background noise. Indeed, if you start to measure the partial discharge, before applying the voltage to the test object, there are some noises. There are background noise related to the environment that the system is set up. In the laboratory, the background noise is under the control. But if you do the on-site measurement of the partial discharge, the background noise will be super challenging. For the better result in the laboratory, you should equip the laboratory with filters, with Faraday cage and different methods to eliminate the background noise that may affect the partial discharge measurement. Based on the background noise that you have, you can have good, satisfying or desired result. Interferences are other challenges for PD measurement. If you have a non-ideal HV source, you can pick up some signals from the high voltage source that are not related to the test object. And you can see high level of the partial discharge levels. On the other hand, the system is working well and it is confusing for interpreting the result. There are some electromagnetic interferences in the environment that you measure the partial discharge. In the lab and laboratories, you can limit the interferences. But in the site, and if you go to the substations and you want to do the after installation test or commissioning test or periodical test, you will have different interferences that affect the PD measurement based on the technology and method that you have selected. For example, if you select the electrical PD measurement technology, they will be affected adversely by the interferences from the source, from the EMI in the environment that you want to do the test. But other technologies like the acoustic emission technologies, they are EMI immune because they pick up the acoustic emission signals and they are not sensitive against the electromagnetic interferences, signals that come from the high voltage source. And sometimes some methods are limited due to the interferences and the impact of the interferences on the result, and you should select another approach. It means, for example, sensitivity of electrical PD measurement is good and satisfying. But if the background noise is high or there are different interferences, you should select another technology. For example, acoustic emission PD measurement technology or others. The last challenges is about the combination of the harmful and non-harmful PDs. For example, if you have some sharpness in the connection of the high voltage electrodes, you see high magnitude of the partial discharge, but it is not dangerous for the asset. Corona or external surface discharge can be solved or fixed by some approaches like the corona ring or others. Or for some systems, there are some internal and hazardous events that appeared in the PD result, and you should focus on that. The level of the PD and the patterns of the PD for different high voltage assets will be different. For example, for the rotating machines, the PD level can be high, around 1 nanocoulomb, 5 nanocoulomb. The phenomena and principles behind the materials that are used for the rotating machines are not hazard, and you say the system is working well. But if you use XLPE as a material for the high voltage and extra high voltage cable systems, the 5 picocoulomb or 10 picocoulomb will be high and dangerous. And you should decide that the partial discharge that you measured for the extra high voltage cable systems are internally or externally. This challenge will be related to the experience of the PD man and who tries to do the test and interpret their results. And if you can manage the challenges that we discussed, you have a good measurement and you can make a good decision about the asset health condition. Today we discussed about the challenges of PD measurement. We listed most important challenges: sensitivity, background noise, interferences, and combination of the harmful and non-harmful PDs. Thank you for watching. We will see you in next episodes.